Honors Chemistry, and welcome to Chapter 13, where we pick up the language we need to talk about chemical reactions that involve solutions in a way that is concise, as opposed to what we've been doing, which is saying 3 grams of sodium chloride, which are dissolved in a certain amount of water, right? Which is annoying and tedious, right? So now we find other ways to discuss solutions. And for the most part, what we are going to talk about is aqueous solutions, okay? So first, let's talk about solution formation at the particle level. First, let's talk about our solvent, right? So clearly, we have solvents, and solvents have attractions between them, right? So this is water molecules, and there is an attraction between one water molecule and its neighboring water molecule. That's called the solvent-solvent attraction, right? It binds those two things together, and in order for something to dissolve, those two particles have to be separated, yes, right? Likewise, we have a solute attraction. So here we have sodium chloride. Those sodium ions are attracted to those chloride ions, and again, that attraction has to be broken or overcome in order for dissolving to occur, right? Both of these processes are endothermic, right? In that they require energy in order for those attractions to be broken, right? On the flip side, we have the solute and solvent attraction, right? When a solute and a solvent particle have a shared force of attraction, right? Going back to the phrasing in your book, it's like dissolves like, right? But when there's a shared force of attraction, then those two particles, the solute and solvent, are attracted to each other, right? And energy is released. So anyway, those are our forces at play. And if we look at what it looks like at the particle level, and yeah, I do expect that you can draw this, right? Here we have our chloride ion, right? Which is negatively charged. And we'll see that the positive end of water preferentially surrounds it, right? And so it's not just a chloride interacting with one water, right? It's a boatload of water molecules that form a shell, right, around that chloride ion, right? And it's always direction specific in that if we look at a water molecule, right, we learned back in somewhere in middle school, right, that water is polar. That's part of what makes it such a fabulous solvent, right? And we can think of it as being this end is the positive end of the molecule, right? And this end is the negative, right? So here we'll see our chloride ion is negative and the positive ends of water are attracted to it. For our cation, the negative ends of water preferentially face that direction, right? And again, we get that shell of water molecules around it, right? And that's what dissolving looks like at the particle level. For something that's not ionic, we get much the same thing, right? Molecular things dissolve in the same way, wherein water molecules have to be able to interact with that molecule, right? Via some kind of force of attraction, shared force of attraction. And we will put more language on that in coming units, okay? The chapter 13 does flash back to the concept of electrolyte solutions, right? Which come into play here. So here we have 5, to be specific, right? So 5 molecules of sugar. 5 molecules of sugar in some water, right? And here it looks like we have a lot of particles, but really, if we pair these up, because bearing in mind this is sodium chloride, right? And if we remember, sodium chloride is ionic, right? Ionic and soluble. Because it is ionic and soluble, that means when it is in water, it will dissociate into its respective ions. So really, this is only 5 formula units of NaCl. But when we put those 5 formula units, they dissociate, and we end up with 5 cations and 5 anions floating around in the solution, which is what gives it the ability to do, right, conduct electricity. Yes? Good? This picture is going to be important. Make sure you tuck it away in your brain because we're going to revisit this towards the back end of chapter 13. All right. And then finally, that gets us to the concept of solubility, right? How do we help enhance the solubility of something? So note that first, this only applies to solid solutes, right? And specifically, we are talking about ionic ones, right, in this graph. And this is what happens for the solubility of solid solutes versus temperature, right? And we will see that for the vast majority of them, as we increase the temperature, what do? Right, we increase the solubility, right? So if we go back a couple of slides, right, we'll see that part of the dissolving process requires some input of energy, right? And so really here what we're doing is we're helping to give some more energy to the solution to get it to dissolve better. Note that what this means though, like so for example, if we were to look at potassium nitrate, right? So if we look here, right, at 40 degrees, this is how much could dissolve, right? So let's say that's about like 62 grams could dissolve at 40 degrees Celsius, right? But do be mindful that if we heated up some water, dissolved our potassium nitrate, and let it cool back down to room temperature, right, which would be about here somewhere, that now our solubility is only sitting at about 30 grams, right? So if we cool that solution back down, its solubility is also going to go back down with it. And we could expect to see what? Right, precipitation, right? As in about 30 grams is going to come out of solution until it goes back to what its maximum solubility, so that it's saturated, using our new language, right? Saturated at 20 degrees Celsius. Yes, does that make sense, right? So these are at their specific temperatures. And you'll see that not every salt follows that rule, right? Some of them don't increase their solubilities with temperature. All right. Again, like it says in your outline, you are not expected to memorize any of these solubilities. You should know how to use a table if you are presented one, which is, I think you can do that. All right. Thank you for listening. Be good. Stay tuned in the next lecture as we talk about gas solutes.